The probability that students become active citizens in the future increases substantially if we encourage them to act now, in the present, creating opportunities for them to do so. Students can, and should, be regarded as being part of the solution of current problems. For that, science education will be crucial to empower them to take on this role.
The development of an interactive scientific exhibition, planned, constructed and presented by students, can be understood as an education initiative for other citizens. It enables students to participate in community action on responsible research and innovation, and motivate others to get involved in it.
Whatever the problematic issue guiding the students' action, they will need scientific knowledge if we expect them to get involved past a superficial level. Substantive knowledge, guided towards action, is crucial to understand the issues underlying the problem, to assess different stances, and to make informed decisions and arguments.
The development of a scientific exhibition is a pretext, and a context, for students to research on their own interests, asking questions, collaborating and performing observation, using logic and evidence in formulating and revising scientific explanations, recognizing and analyzing alternative explanations and communicating scientific arguments.
By developing and presenting exhibitions on responsible research and innovation, both students and teachers have the opportunity to contact with themes that highlight a frontier science, controversial, uncertain and under debate.
The discussion inherent to the preparation of exhibits on responsible research and innovation can be particularly useful both in terms of learning about the contents, the processes and the nature of science and technology, and in terms of the students' cognitive, social, political, moral, and ethical development.
Truly interactive exhibitions are those that change their presentation as a function of the visitor's response. Interactivity does not necessarily require a physical action from the visitor, nor the use of technology as mediator between the object and the visitor. Regarding the interaction between visitors and objects that takes place in science museums, there can be defined three levels of interactivity: manual or hands-on, mental or minds-on, cultural or heart-on. The ideal situation would be for their simultaneous presence. However, in a gradient of importance, manual interactivity is seen as convenient, cultural interactivity as desirable, and mental interactivity as essential.
The socio-cultural theory of learning emphasizes the idea that meaning emerges from the interaction between individuals that act on social contexts. The social interaction amongst the visitors of an exhibit is, probably, one of the biggest contributions of museums for the current-day social dynamics.
In the absence of mediators, it is the responsibility of the objects themselves to promote the social interaction that supports the visitor's understanding and knowledge development. The objects must encourage the visitors to interact amongst themselves and with the exhibition.
Opportunities should be created, allowing the visitors to establish a continued interaction, and providing resources for them to model and creatively reconfigure each other's experiences. The exhibition's design should facilitate the transformation of the exhibition, being supported by a collaboration, which may, itself, leave a trail of activity for future visitors.
The object should actively involve the visitor, assigning him tasks to perform, which allow the application of new knowledge that is presented throughout the exhibition. It is also important to stimulate reflection on the experience that is taking place. Questions posed in the beginning, middle, or end of the exhibit, or object exploration, direct the visitor's attention, raise issues and promote discussion, engaging the visitors with each other and with the object.
Questions that are too obvious, or highly directed, are of little interest since they are not supportive of the level of engagement intended. Personal and speculative questions are the best ones when looking for authentic and diverse answers. If a question is used, it should demonstrate a real willingness to learn about the visitor's answers, making it possible to record them.
The best way to invite strangers to interact comfortably between themselves is to give them explicit instructions on how to do it. If we intend to develop objects as social artifacts, it is important to clarify some engagement rules with the objects, or the social contexts surrounding them. The process of creating an exhibition can be organized into 3 different stages: pre-production, production and post-production. The pre-production stage includes the initial research behind the exhibit and the design of the actual exhibit.
There are 5 basic research steps: clarifying the research questions, locating information, summarizing information, analyzing information, and synthesizing information.
When research is complete, students are ready to design their exhibit. This task can be developed with the use of several guiding questions. What will we use to tell our story? How will we get visitors to experience our story? What will our complete exhibit look like? Will our exhibit work?
At the production stage, students will focus on implementing the exhibit design. Having done the hard work of research and design, they are now eager to construct their displays. Students should complete a formal construction plan, which outlines tasks that each team must accomplish in the upcoming days, who will complete them, and when they should be done. They should also list all the material, supplies, and equipment necessary to construct their exhibit. When students have completed construction of their displays, they are ready to install the exhibits in the exhibition space.
Finally, at the post-production stage, students will focus on getting feedback from visitors. Students can develop different strategies of assessment to determine what visitors liked and learned, namely, observations, exit surveys, and questionnaires. Students should later summarize this information and have a reflected discussion about what made certain exhibits highly appealing to visitors. There are many possibilities of building objects that can attract visitors' attention and promote interactivity. For instance, students can build posters, which can be physical or digital.
Another option is to develop books, both physical or digital, which for example, reports the research developed by students, or tell a story created by them. The story may be in a comic book format.
And why not design and create a game? It's an excellent way to engage multiple visitors at once. Students can choose to develop a video, which can take several formats. For instance, it can be a student research report, student testimonies about their work, a newscast or a role play, an activity dramatized by the students.